Hello guys, my name is Aarav Pradhan, and for today I will be talking about physical and chemical changes. Before I start the video, I just want to tell you I don't have a good microphone, so the audio may come out bad. So let's start. What are changes? Changes are basically when the properties of a thing, change. Hence the name changes. They happen every second of every day, in every room of every building, and everywhere at any time, which is why yes, you can even watch this video. You might have encountered something like this when, for instance, the ice in your drink melted, or the incense stick you lit burned away. Since there are many types of changes, we have divided them into two parts: physical and chemical changes. So, let's start with physical changes. What are physical changes? They are defined as changes which are completely physical in nature, which means the changes can only occur with their shape, size, color, and stuff like that. This also means that no chemical properties are changed. You are probably wondering what chemical properties I'm talking about. So let me talk about chemical changes. Chemical changes, unlike physical changes, are changes which occur in the object's composition. This also means that new substances are formed from these changes. You probably won't understand what chemical properties I am talking about. So it's time that I explain to you what they are. An atom is the smallest unit of matter or substance. Some things only have one type of them, while others have many different types. It's like choosing types of candy. You may only like one type, or you may want many types at the same time. You might have heard of them before. If you have ever heard of H2O, you might know that it is a chemical composition of water, being made up of two hydrogen atoms and one oxygen atom. Scientists have also subdivided these into two groups, that being elements and compounds. Elements are made of only one type of atom. They cannot be broken down into simpler types of matter, so they are as simple as they can be. There are 118 known elements as of the time I'm writing this, so all elements must be from one of these atoms. Compounds are much more complex though, as they are combinations of different atoms. They are always in a fixed proportion, so you only have to remember them once. Now, how do we make sense of these? You won't understand if I just start saying carbon, oxygen, carbon, hydrogen, etc. But if I list them out as C6, H12, O6, you start to understand the chemical composition. In fact, you may know that that is the chemical composition of glucose. So, what symbols and formulae do we need to use? Well, there are a lot of them, but luckily we are in grade 7, so it doesn't even matter. Still though, we must learn the basics if we want to be ready for what's coming after. I have shown on the screen some of them, with their names, symbols, and their original Latin names all shown. Next time you go into the examination hall, say thanks to the International Union of Pure and Applied Science for shortening the names of these atoms so you don't have to write them out every single time. Like seriously, I have finger pain just remembering typing these names again and again. Have you remembered that? Well, good, because there are more tables on the way. Here are some elements and their formulae, followed by some compounds and their formulae. It looks like a lot, but trust me, it's actually really simple. Now, here's the hardest of all. We need to do some chemical equations. Every chemical change has a corresponding reaction, which shows what change has taken place. There are two sides to a reaction: the reactants and the product. The reactants are what was there before the reaction takes place, while the product is what was there after reaction happens. I'll show on screen some textbook examples of these reactions, which, for 7th grade, is a little much, but this is how you will understand. Now, these reactions are really complex, so for now we will discuss four types, being single displacement, double displacement, synthesis, and decomposition reactions. Let's discuss these one by one, showing examples on the screen as I go along. Synthesis reactions are just two substances coming together, shown by A plus B equals AB. Really simple. Decomposition reactions are two substances breaking apart from each other, as in AB equals A plus B. Basically just the opposite from synthesis reactions. Single displacement reactions are where a single atom gets displaced and replaced by another, shown by AB plus C equals AC plus B. Double displacement reactions are just the same, but instead two atoms get displaced and replaced. You got that? I didn't either. Go home and Google it. I'm really tired. I've been typing for 1.5 hours. Now, there are many other types of chemical reactions that take place, so I will explain all of them to you now. There are exothermic and endothermic reactions, which are not the same as the ones you have learned in SST. Exothermic reactions are the ones which produce lots of heat, while endothermic reactions absorb the produced heat as shown. Now, before we conclude, let's discuss the processes that happen to a certain material, iron. Iron undergoes a special reaction when it's left in a humid environment, and that is rusting. It happens when it's left out for a long time and it eats away at the metal, making it less durable. As Fe converts to Fe2O2, the chemical composition of rust. How do we prevent these losses, however? There are many ways to do so, like greasing, galvanization, electroplasting, and converting iron into stainless steel. But I am exhausted and we might as well end the video here. Also, ma'am, can you kindly please show the end of credits of this video? I would appreciate if you did. It takes a lot of work to make high quality content like this, so I would like to shout out all the people who have made this possible.